Hey guys, welcome back. In a minute we're going to start RLC Series circuits. We've just finished learning about capacitive reactance and how it is equal to 1 over 2 pi FC, and I gave you some homework to practice that. We also learned how to add capacitors in, when they're connected in series and parallel, blah blah blah. That's all done now, and so we're going to start looking at RLC series circuits, which is basically a circuit that has resistor, inductor, and capacitor all in series. Before we do that, though, we have to talk about how a capacitor behaves in an AC circuit, because we know that with a resistor, guys, that if I looked at a resistor with a scope, AC connected to AC, we would have the current and the voltage in phase, and if I drew the sine waves, it would look like that. If I drew the phasors, it would look like that. We've also learned about inductors. We said that inductors cause the current to lag by 90, and so if I looked at the phasors or the sine waves with a scope, I would see that the voltage was here and the current was lagging by 90. Well, with capacitors, it's the opposite of inductors, and I've got a note up here for you. It says in AC, capacitors always cause the current to lead the voltage by 90 degrees. And so if I took a look at a capacitor here with a scope in an AC circuit, what I would see is the voltage here and the current leading by 90 degrees. And this is just a fact, guys. It's just something that happens with AC. If you look at the notes that we were taking in a previous video here, this is in DC here, and we decided that if I close the switch here, I would get a big bump in current, which would taper off, and then I would get the voltage coming up later. And same with here. If I turn the if I discharge this thing, I'd get a bunch of current right away, and then I would get the voltage coming later. So here you can see the current is leading, whatever the voltage is lagging, and that's occurring when I change the circuit. Well, in AC, the circuit's changing all the time, and so the current is leading all the time. And it literally would look like this. Okay, guys? Leading the voltage by 90 degrees. Just a fact, just something that you have to be aware so that we can figure out what's going on with RL series circuits. In an RL series circuit, we're going to have one component that's in phase, one component that causes the current to lag, and one component that causes the current to lead. Okay, so tune into the next video and we'll look at some RL series circuits. Okay, guys? Have a good one.